you know what the absolute value function is. Like you graph it in grade 11, so you've seen this before. And there's not a whole lot new here, so it's mostly review. But again, just in general, thinking about the idea of what is a function, why do we care about them? What are they used for? What is the point of graphing? What's the point of any of this, right? So keep that in mind. So this stuff is review and easy, I think. But keep in mind that we are trying to reflect on some of these ideas because it is going to progress in a few days. It's going to start getting harder. Okay, absolute value of anything is what? Like, what is the point of the absolute value function? It's always positive. Okay, what it is a measurement of the distance from 0, but no indication of direction. What is a number? The number 5 is how many units you are away from 0. Like if you picture the Cartesian plane and our origin 0, 0, if I go to 5 on the x, I'm 5 units away from 0. But that has a direction because I went positive 5. It tells me which way to go. Positive 5, or if I say negative 5, that's still a distance of 5 from the origin or from 0, but it's just the other direction, right? So the negative tells you to go the other way. Well, absolute value takes away direction, and all it does is tell us the magnitude, or tell us how far from 0 it is. We don't care, apparently, in that case, what direction you are. Just care how far. Okay? So how does this impact input versus output? A little bit like we talked about yesterday. So what is the absolute value of 3? This is a hard one. 3. And what's the absolute value of negative 3? Also 3. Right? So there's a quick review of what the absolute value does. It gets rid of the sign. And you can think of it as like always positive, but in some ways you can also think of it just doesn't really have a sign. Like we call it positive, absolutely, but the sign's gone. Whether it was positive or it was negative, now it's just positive no matter what, right? So I'm distance 3, right? The distance from 0 is 3, and even if I go this way, I went to negative 3, but the distance is 3, like a length. A length is always positive, right? So it's a length, or it's a measurement, or it's a magnitude. Sometimes we call it that. Okay. How does this impact input versus output? So that's kind of like asking, what does the graph look like? Well, if I go, so there we go. F at x equals the absolute value of x. We're going to graph this. So you can just sketch it. You don't need a grid if you don't have it printed out. You can just sketch it. So the absolute value of 0. Whoops. The absolute value of 0 is 0. The absolute value of 1 is 1. 2 is 2. 3, we already did that one. 3, 4 is 4. Right? What's the absolute value of negative 1? It's also 1. Negative 2, 2, negative 3, 3, negative 4, 4. And that should be a familiar look from grade 11. You do a lot of graphing absolute value in grade 11. So yesterday we talked a little bit about quadratics. We talked a little bit about the square root function, sort of, and it was on the learning goal. And we talked a bit about functions in general. And like we saw some different examples of functions. We saw a reciprocal function. Well, here's an absolute value function. Review from grade 11. That's what it looks like. What's the domain? What's the range? Where do the ends point? Like, what is it like? What's its nature? How is it different from other functions like a quadratic? How is it the same? Right? It has some similarities to a quadratic, doesn't it? But then it has some differences as well. Okay, pretty easy so far. This is a little bit new, I think. How do we take this is what we call absolute value notation. How do I draw that on a single number line? So what do you think? The absolute value of x is less than or equal to 4. So what I'm going to do is I'm going to start thinking about values for which this is true. What if I put 3 in for x? What if I put 0? Let's start with 0. Put 0 in for x. It's true. Okay, so 0 is going to be included. You don't have to plot them yet. We don't really plot points, but I'm just going to do it for our thinking right now. What about positive 1, positive 2, positive 3? Are they good? Yeah. Positive 4 is less than or equal to 4. Yeah. What about the absolute value of negative 1? Negative 2, negative 3, negative 4. What about the absolute value of negative 5? Because negative 5 is less than 4, but the absolute value of negative 5 is 5, which is bigger than, so 5 won't work. So it looks like my cutoff is negative 4, and then obviously if I go up to 5, that's bigger than 4, so that's not less than or equal to 4. Okay, and so how would we show that? We'd show that by sort of coloring in. And you may have seen this notation somewhere, but a colored in circle is inclusive, right? So I use a colored in circle because it said less than or equal to 4. Does that make sense? If I was using set notation, that would look like this. Negative 4 is less than or equal to x is less than or equal to 4, right? You recognize that from domain and range. That's what we mean by set notation. Okay. What about this? The absolute value of x is greater than 2. This is interesting. Like this, what are we doing here? We're plotting something on a single number line. It's like the Cartesian plane, but there's no y, right? The Cartesian plane is two-dimensional because you have x and then you add a y. You don't really think about it when you start doing that in elementary school or grade 9 when you do a lot of it. But right, it's two-dimensional. Well, what if we plot things on one-dimensional, like a number line, right? So there's no y, there's only an x. So what about 0? What is the absolute value of 0? Is it true? Not greater than 2. What about 1? No. What about 2? No. 3? Yes, 3 is greater than 2. 4 is greater than 2. 5 is greater than 2. So starting at 2 and going up, and notice how it's not filled in circle, right? It's an empty circle because that does not include 2. Does that make sense? And we put an arrow to show that it keeps going to the right forever. So this graph isn't finished though. What else do I need? What do you think? Good. And go the other way. Because the absolute value of negative 3 is 3, which is greater than 2. Right? Does that make sense? So some people, I think, I know this is not rocket science. Right? This is not super hard. And some people just might kind of memorize, oh, if it's pointing this way, then I do this. If it's pointing that way, I do that. But there is thinking and understanding that goes along with this, right? Like there is like the idea of, is it true or not that this value of x will work for this statement? Like that is the underlying thinking that should go into this. Does that make sense? Everybody good? Okay. You might want to write this down. This is just a little bit of a refresher on function notation because there's a little bit of, yeah. Oh, okay. Get the homework questions from online, from textbook. Yep.
I was wondering what the set notation would look like for the last example.
It would just look like x is greater than 2 or x is less than negative 2. You would have to write it in two separate statements. There's no like formality of writing it in one line or something like that. You would write it in two separate things. That's not something, well, it kind of comes up, but not formally, really. You're asked to write it that way. But knowing the difference between writing it on a number line or using set notation, that's something that you want to start thinking about. Different ways that we write answers. Set notation, we'll talk about interval notation as well later. Okay, so let's say I have y equals f of x. That's just a general function. I don't know what it's like. I don't know what it looks like. And in fact, in grade 11, you probably did some stuff where your function is just like random. Like there's not an equation for it. Did you do this kind of stuff where it just goes like that? Do anything like that? And you can do a transformation of it, right? So anyway, so there's no equation for it. It's just a general function. That's what this is talking about. And then here it is with all of the transformations that we know. That's how it would look, right? So what is A? We're going to do this formally later, but to remind you and make you familiar with it, something to think about. A tells me if there's a reflection in the x-axis and if there is a vertical stretch or vertical compression. K, and so that's what it looks like in the general form. And what if it was absolute value, or what if it was quadratic? It looks very similar. K could be a reflection in the y-axis, which doesn't do much for an absolute value function or quadratic, but could be, right? And it would be a horizontal stretch or compression. And then C is the horizontal shift, left or right, and D is the vertical shift or vertical translation, up or down, right? So thinking about how it looks just in general form, and then in two particular situations, quadratic that we're very familiar with, and absolute value function. There's a little bit of graphing in the practice today. Okay, don't write this down. It is in your textbook right before this section, but I want you to read it. So I'm going to leave it up here, but you can also look it up in your book if you'd rather have it on your desk. I want you to read it. And you can start working on A, B, C, D, E. If you need to chat with the person beside you, you can do that. Oh, here's your practice, page 16, 1 to 10, if you want to write that down. And then I'm going to put the paragraph back up. And give you maybe 10 minutes to sort of read through it and think about, especially the first few, like A, B, C, D. And then we're just going to chat about it quickly, and then you can do some of the practice from the text. Page 16, 1 to 10.